So here is a new video on how to include trade relations with the rest of the world. You again have an assignment to complete, and this assignment is more difficult than the previous ones. So we give you more time to complete it, and so it's really feasible. And of course, we are still here to help you. So, how will trade relations with the rest of the world modify the computable general equilibrium model that we have designed until now? There are several consequences. The first one is that we have something new, which is exports and imports of goods and services. And so this implies a new supply and demand of goods and services. A new supply because imports are a new source of supply of goods and services. This is a supply from foreign producers. And a new demand of goods and services because exports are a new destinations for the national production of goods and services because exports are foreign demands of national goods and services. So this also implies a new source of fiscal revenues, in particular if the government applies custom duties, import duties, but also export taxes. And it means also that we may have either a positive or a negative current account, a surplus or a deficit, or what we also call a goods and services account or an external account. You know the macroeconomic interpretations of that. So if there is a positive external account, it means that the nations accumulate debts over foreign agents. If there is a deficit, it means that the rest of the world accumulates debts over national agents. Last element, we are going to have in this new model a connection between domestic prices and world prices because in fact we are in an open economy, and so we must have a connection between domestic prices, local prices and world prices. Maybe there would be a gap between domestic prices and world prices, but this connection will exist. So we make several assumptions with the objective of simplifying the introductions of relations with the rest of the world. In this regard, the key assumption is really an assumption of homogeneous goods. So it means that within each sector, the local good is identical to the foreign good. It means that they are perfect substitutes. And it simplifies a lot the modeling of trade relations with the rest of the world. Second assumption that also simplifies greatly the model is that we only have import taxes. We don't have export taxes, we don't have import quotas, and so on. This implies that the relations between local prices and foreign prices is very simple. Local prices can be greater than the world price because of import taxes, and the relations is P in sector I, the local price, is equal to the world price, PE in sector I, times 1 plus the import tax, TM in sector I. So import taxes can be differentiated from one sector to the other, and if there is no import tax, the local price is aligned on the world price. We do not suppose transportation costs to simplify the model. And if the import tax is positive, the local price is greater than the world price. Of course, there are several potential generalizations. These generalizations will be conducted during the second curriculum. We can have an imperfect substitution between local goods and foreign goods. We can also introduce export taxes, and both types of generalizations will be explained during the second curriculum. Well, the assumptions of homogeneous goods has a direct consequence. Within a sector, since local goods and foreign goods are perfect substitutes, then either they are exports or they are imports. But you cannot have both at the same time. You cannot have what we call two-way trade, that is to say, simultaneously exports and imports. If you have homogeneous goods, then you have one-way trade, that is to say, either exports or imports. Another simple explanation is that with homogeneous goods, you know that we've got a unique local price of a unique good, which is either produced by local firms or by foreign firms, but this is exactly the same good. So it's a unique price. So homogeneous goods implies one-way trade, that is to say either exports or imports. And we are going to model trade flows with a unique variable, which we are going to call ED in sector I. This means country's excess demand for good I. So either ED in sector I, you understand what it means. It is demand minus supply. So either ED is positive, it means that demand is greater than supply, so there are imports, or ED is negative, so it means that demand is less than supply, it means that there are exports. And the foreign account, the trade sold, exactly we should call it the sold in goods and services. So this equation is very simple because it is trade sold equal to sum over I of PE in sector I times minus ED in sector I. So first, we use world prices because economists are used to measure foreign account at world prices and not at domestic prices. And then we've got minus ED in sector I because either ED is positive, it means that we've got imports. So you understand that the trade sold is exports minus imports. So we subtract imports. Or ED is negative, and so it means that minus ED is positive, and so it means that in sector I we've got exports, and so we have to add exports. So let us consider the world price. Of course, we could assume that the world price is constant, but it's not very interesting. In fact, any country has a market power on the world market. The assumption of small country, that is to say no market power, is just presented for pedagogic reasons. Any country has a market power on the world market. The problem is that in the case of small countries, the impact is very small, and maybe it is tiny. In the case of large country, the impact is substantial. So the problem is to be very careful with the selections of the elasticity. So we implement here an assumption of large country, and we will be very careful in the selections of the elasticity to make a differentiation between countries with a small or even tiny market power and countries with a significant market power. Okay, so we have the assumption that the world price varies with exports or imports of this country. So we've got a relations which is ED in sector I is equal to F in sector I, a constant, times PE in sector I, that is to say the world price, at the power sigma in sector I. So in fact, this is an equation which determines the world price in sector I. So I'm trying to explain this point. either we've got supply or demand of imports or exports by the rest of the world. I mean, if ED is positive in sector I, we've got imports in sector I. So this equation means that the rest of the world is ready to supply the quantity ED at price PE in sector I. And if ED is negative, it means that we've got exports, and this equation means that the rest of the world is ready to demand a quantity ED at price PE. So this is, you have to understand these equations as an equations of determinations of the world price in sector I. And in fact, it is either a supply of imports by the rest of the world or a demand of national exports by the rest of the world. And in fact, with ED positive imports, we've got F in sector I, which is positive. While if ED is negative, we've got exports and we've got F in sector I, which is negative. So in fact, F and ED have exactly the same sign. Why? Because in these equations, you've got on the left side ED, which is either positive or negative. On the right side, you've got PE at the power sigma. PE is always positive, of course, because it is a price. So at the power sigma, it means that PE at the power sigma will be always positive. So it means that ED has the same sign as F in sector I. So if ED is positive, F is positive. These are imports. If ED is negative, these are exports, and F in sector I is negative. And finally, I would like to explain sigma, which can be either positive or negative. And this is exactly the same thing. If sigma is positive, we've got in sector I imports, that is to say ED is positive. And why sigma is positive? This is because when imports augment, world price augments. That is to say, when ED augments, PE augments. On the contrary, if we have exports in sector I, it means that ED is negative and sigma is also negative. Why? Because when exports augment, the world price decreases. You have to understand that imports is a demand to the world markets and exports is a supply to the world markets. So when demand on the world market augments, the price augments, the world price augments, and when supply on the world market augments, the world price decreases. The problem is to understand how the goods market equilibrium equations are modified. That is to say, the demand equal to supply equations are modified by the introductions of either exports or imports. So this is very simple. You remember that in the previous model, the equations was production in sector I is equal to demand by household, C, in sector I, plus demand for by public administration, that is to say CG in sector I, plus demand by firms, either for intermediate consumptions or for capital, for investment reason. And so right now the new equations is simply C in sector I plus sum over J of Cij of good I by sector J plus Ck in sector I plus Cg in sector I plus minus Ed in sector I must be equal to Y in sector I. The explanation is very simple because either Ed in sector I is positive, so we have imports in this sector, and this is a new source of supply of goods and services. And so with ED positive, we have minus ED, which is negative. So you can put minus ED on the right side of the equation if you want to understand it under a traditional configuration. And so on the left side, you have demand by household, by firms, by public administrations. On the right side, you've got two sources of supply: local supply, production, and imports. Or ED is negative, and so you've got exports, and so it's a new source of demand for goods produced by local firms. So it means that with ED in sector I negative, you've got minus ED in sector I, which is positive. You can keep, in fact, minus ED on the left side, and so you've got on the right side the only source of supply of goods and services, which is Y, which is the local production. And on the left side, you've got 5 types of demand, either by household, by public administrations, 2 demands by firms, intermediate or capital, and then by foreign agent. This is exports. There is a new source of fiscal revenues with these custom revenues. And we only consider here custom revenues from tariff applies on imports. So we do not consider any export tax, we do not consider any quota on imports, only tariffs on imports. So what is the amount of custom revenues by sectors? It's very simple, because you've got ED in sector I, which is the imports in volume. So if you multiply ED by PE in sector I, you've got the value of imports in sector I at world prices. And this is exactly the basis of taxation. So if you multiply this by the custom duty, TM in sector I, you've got custom revenues by sector, TM in sector I times PE in sector I times ED in sector I. So, in fact, there is a problem with total custom revenues. Why? Because, in fact, you have to obtain these total custom revenues to sum custom revenues by sectors over all sectors. But the problem is that you've got sectors without any imports. So you must add a condition. I remind you that the conditions in GAMS, it is expressed by $. So you have to sum over I custom revenues by sectors, but with one condition, which is $. And the condition is you must have ED, which is positive in sector I. So if it is positive, you must have it in the sum, in the addition, while if ED in sector I is negative, you must not select ED in sector I and this sector to get total custom revenues. Now we have to understand how trade relations with the rest of the world modify the macroeconomic equilibrium. I remind you that in the last Computable General Equilibrium model, we expressed a macroeconomic equilibrium, but it was a relation characterizing a closed economy. And it was savings minus investment plus public sold is equal to 0. And so savings, it's private savings. And so in the model, it was savings by households minus investment by firms in the model plus public sold, which is either a deficit or a surplus by public administration. And so in an open economy, it's different, because this macroeconomic equilibrium becomes savings minus investment plus public sold must be equal to the external account, the trade sold variable. And the idea is that we've got a new agent, the rest of the world, which has either a capacity of financing or a demand for financing. And so either the external account is positive, the economy finances the rest of the world, or it is negative and the economy is financed by the rest of the world. So the first case, if you've got the positive external account, it's, for example, the case of a country where savings are very high, and so they are enough to finance private investment, but also the public deficit. And after financing private investment and the public deficit, there are enough savings to finance the rest of the world. While in an economy with a deficit, an external deficit, so take the example of the US economy, private savings by households are very low. The demands for financing by private firms for investment reason is very high, and the public deficit is also very high, and so it implies external deficit. So you need a social accounting matrix to get some data to fit the model. So here is the social accounting matrix with relations with the rest of the world. So you've got level of production in each sector. Then you have a new source of supply, which is imports, and there are only imports in the industrial sector. Then you've got indirect taxation. Of course, it is taxations on products sold by local firms, but it is also custom duties. And you have only imports in the industrial sector, so you've got only custom duties in the industrial sector for an amount of 300. So this is something that you have to keep in mind. There are custom duties, custom revenues in the industrial sector for 300, and this is the only sector with custom revenue. Then you've got the intermediate consumption matrix of the good in row by the sector in column. Then you've got remunerations of productive factors, labor and capital. And then you've got the formations of income, that is to say, the labor remuneration goes to households. The remunerations of capital goes to enterprises that distribute profits to households. And so with this income, households finance several things. First, the payment of income taxation to public administration. Then a demand for goods and services in each sector. Then household save money for an amount of 1,850. Public administration, they have a demand for goods and services in each sector. And since you have too much expenses as compared to revenues, you've got a public deficit. And so at the row accumulations of capital, you've got a new element, which is the public deficit. Then you've got investment, which is a demand for goods and services to each sector. And then you have another source of demand. In the previous social accounting matrix, you've got only final consumption, public consumption, demand for firms either for intermediate consumption or for investment. And now you have the demand from the rest of the world, that is to say exports. And you've got exports in agriculture and in services. If you look at the raw accumulation of capital, you see that in fact you've got savings by households, public deficit. And in column, you've got investment, which is also a demand for financing. And you've got also a current deficit of minus 150. So you have all the elements to design a computable general equilibrium model with right now relations with the rest of the world. And you can calibrate it with the previous social accounting matrix. You will have 2 slides just after this one that will expose entirely the model. Concerning the calibrations, I have one element I would like to talk about. In previous calibration, we normalized consumer price P0 in sector I equal to 1. But right now, with relations with the rest of the world, we've got a problem because, in fact, if you look at the model, we have a relation between consumer price and world price, which is P in sector I is equal to PE in sector I times 1 plus TM in sector I. And so you can use these relations of the model to calibrate PE0 in sector I equal to P0 in sector I over 1 plus Tm in sector I. So once you have normalized P0 to 1, you can calibrate PE0 with P0. The problem is that you do not know Tm in sector I. You do not know the import duty in each sector. What you know is only the amount collected by public administration. Okay, so we have in fact to calibrate, before calibrating PE0, we have to calibrate Tm in sector I. How can we do that? So if you think about it, you can use a sheet of paper and do some math. Because in fact you can start with the previous equation, multiply by ED0 in sector I, and you've got something which is after development, P0 times ED0 is equal to PE0 times ED0 plus PE0 times Tm in sector I times ED0 in sector I. And the last element of this right side is in fact the amount collected by public administration by sector. So it is what we can call import call in sector I, and this is something that we have in the social accounting matrix. So you can use this to maybe to calibrate Tm in sector I, because you can write PE0 in sector I times Tm in sector I times ED0 in sector I is equal to import call in sector I. And so you can derive from that Tm in sector I is equal to import call in sector I over PE0 in sector I times ED0 in sector I. The problem is that you do not know PE0. You only know P0. So you have to replace the denominator PE0 times ED0 by P0 times ED0 minus import call in sector I. This is obvious from the previous equations. And so with that formula, you've got something to calibrate Tm in sector I. So once you have normalized P0 to 1, you can calibrate Tm in sector I, and then you can calibrate PE0 in sector I. I would like you to study a shock, which is a decrease by 10% of indirect tax rates.